2.2. Picking up where we left off yesterday. So if you will, please follow along in the notes. Set the iPads aside, set the other stuff aside, and you will have some time at the end of class to continue working on homework. I asked you while I was getting attendance to try the second example in problem 3. So maybe you've had a little bit of luck and tried it. Notice it says, suppose y varies directly with x. What equations does that tell me I can use? What are my direct variation equations? Okay. The 2 I used on the last question. Good answer. The 2 listed at the top of the page, yes?
Yes.
Okay, so we can use y equals kx and k equals y over x. Now, as you read the next part of the sentence, it tells us y is 15 when x is 3. And what I'm going to say, like yesterday, don't worry about the actual question yet. Okay, just worry about getting the setup. So it tells us y is 15, x is 3. If they're giving us an x and a y value, what can I do with those?
You can divide them. You can do the x.
We can divide them, and that's going to find...
You're going to get... I got 5 over 1.
Okay. And the key is that is my k value, right? Once you know an xy pair, you can use that to find k, your constant of variation.
Would you still win at 5 over 1, or could you do it?
I would always reduce. So, if we say...
It's 15 over 3, that's after.
Okay, so y is 15 divided by 3, which is x. So, I definitely would not leave it as 15 over 3. Now, I'm hearing up here 5 over 1. I would go one more step. What is 5 over 1?
5.
It's 5. So if you can give that whole number 5, I would. I mean, honestly, my brain looks at this as, 15 divided by 3, and I'm just going to go straight to 5. So now what I know, k is 5. So not finding the answer yet, what is my equation that represents direct variation?
Y equals k times x.
Okay, y equals k times x, but what do we have to fill in for k? 5. So we can use the equation y equals
5 times 12.
5x is, if I'm just looking, you're a step ahead of me.
Yes.
If I'm just looking for the equation that represents the direct variation, if I ever just ask for the equation, I'm looking for y equals 5x. Because now I can use that equation on any information they give me. In this particular problem, they now say, what is y when x is 12? So what are you going to do with that 12?
Plug it in for x.
Plug it in for x. Right there. And 5 times 12 is 60. Okay. That's a big thing to be able to do with direct variation. We're getting ready to apply it in some possible word problems. Okay. Yeah, I'm not skipping the word problems. We're doing them. And on the back side, we're doing graphs.
Even worse.
Woo! Okay. 2 of the biggies today, right? The 2 big things you guys absolutely love. Word problems and graphs. No? Okay. Okay. Example 4, please. Let's start by reading it. Okay. A salesperson's commission varies directly with sales. For $1,000 in sales, the commission is $85. What is the commission for $2,300 in sales? Now, there's going to be multiple different ways you can do this. You may not do it the same way I'm going to do it. But do you notice how this problem is similar to the last problem we did?
Yeah, they're just not linked.
Yeah. Last time, instead of saying x equals and y equals, they're telling me 2 amounts. So it's just a different setup of the same type problem. Yeah. But notice, first things first, it says salesperson commission varies directly with sales. So if we think in terms of a question, or as an equation. Well, earlier it was y varies directly with x, and that was the equation, y equals kx, right? This time it's commission varies directly with sales. So if you think about that equation, y equals kx, what is commission? Commission, well, not a number right now, but commission is what variable? We're going to use y because it's y varies directly with
Numbers.
x, right? In this case, x is sales. So what we're kind of thinking here is y equals k times x. And so the key is that commission is going to be my y value. Sales are going to be my x values. So as we continue reading, I like to label stuff. Okay, it helps me be able to explain it. For $1,000 in sales, is that an X or a Y value? Sales is X, so $1,000 is going to be an X value. The commission is $85.
So that's your Y value.
So commission, we talked about. Were we just given an X and a Y value?
Yes.
And once you have an X and Y value, what can we use those to find?
Your K value.
Your K value, right? Are you guys with me here?
Yes.
I've got 2 people with me, I know. What about the rest of us?
I don't think they are.
Trouble sometimes.
You're so harsh. Exactly.
Okay. I've got some people I can tell following along, but I've got some people staring off in space, I feel like. So that's why I'm checking. Okay, so if we say K equals YX, K equals, what did we say Y was going to be?
85.
85 over X,
1,000.
1,000.
Equals numbers.
Well, this is the fraction 85 1,000ths. You can leave it as a fraction. You can reduce it as a fraction. But on the flip side, we're also talking money, which we tend to think decimals.
So you could divide it.
So what is 85 thousandths as a decimal? It is. Sorry, I had an extra decimal in my brain, which is why I was questioning you for a moment. Okay. Remember, tenths, hundredths, thousandths?
Yes.
So this is 85 thousandths. Or, your calculator can tell you this by doing 85
Divided by.
divided by 100. Numerator divided by denominator. Okay? So now, what is the equation I'm using to finish the rest of this problem?
Y equals K times X.
Okay. So if we say y equals k times x, but what is k?
0.85. Times 1,000.
So we're going to have y equals kx, which is y equals 0.085x. Okay, well, what is the question we're being asked? What is the commission? Which variable is commission? Y. So what is the y value for $2,300 in sales? Sales is my X. And so, what am I going to put in for X? $2,300. So 0.085 times 2,300. This is one I would let the calculator do the magic on. Not that you couldn't multiply it on paper, but this is a good calculator one. What'd you guys get?
195.5. Do the word. Yeah.
195.5. How do we express that appropriately for this problem?
Dollar sign.
Okay. $195. And then because it is dollars, I am going to tack on the extra zero to say $195.50. Okay. Did we follow that okay?
Yes.
Yeah. Actually, it was more.
I promise, words aren't always horrible.
I don't want to do it again.
I'm not saying all word problems are great, but they're not always bad either. So, okay. Let's practice with this next one then. You've seen the idea. It's a totally different problem, but same idea. The number of calories varies directly with the mass of cheese. If 50 grams of cheese contains 200 calories, how many calories are in 70 grams of cheese? My C in calories disappeared.
Calories.
Yeah.
How many calories?
Okay, so here's my recommendation. Look at that first sentence.
Cheese.
The number of calories varies directly
With the mass.
with the mass of cheese. So,
Cheese.
okay. What is our equation for direct variation?
Y equals KX.
Y equals K times X. So that means number of calories is my Y value equals K times X, and X represents
Cheese.
mass of cheese. Okay? Continue reading. If 50 grams of cheese contains 200 calories, 50 grams of cheese, 200 calories. My question, as always, what's X? What's Y? Go back to what we labeled at the beginning. 50 grams of cheese. Which one is that? That is your mass of the cheese. Contains 200 calories. That is my
Y.
Y. We have an X and a Y value. You two don't answer. We have an X and a Y value. What are we going to use those to find? K. Okay. Hey, at least it was a different voice. That's what I was going for here. So I'm going to use the equation. K equals Y over X. 200 divided by 50. What's 200 divided by 50?
4.
Okay. What's the equation we're going to use? Just a generic direct variation equation here. Yeah, we've got K is 4. So we're going to use Y equals 4X. Okay, if you haven't finished reading the problem, how many calories are in 70 grams of cheese? So how many calories? What am I trying to find? Calories is
Y.
Y. 70 grams of cheese,
You're at it.
X. So Y equals 4 times 70, which is
280. $280 calories.
okay. I was going to say 280 what? And we were being asked how many calories, so this should be labeled as
Calories.
calories.
28 calories.
That is a lot. That's a lot of calories.
What? Cheese.
Okay. Yeah, we need on that side and then turn and look at the graphs. We are going to look at graphs now. These are very basic graphs today, okay? This chapter does involve some graphing. This is not going to be the last of the graphing in this chapter, so just beware, okay? Now, with that being said, don't wait 5 days down the road to decide to jump in and try the graphing with me. Start today with me, okay? That way we can work our way up, take the baby steps. Now, the graphs that we are graphing today, notice it says, what is the graph of each direct variation equation? So that means, since these are direct variation equations, these are all in the form y equals some number times x. So that makes the graphing pretty easy. First of all, because they're y equals a number times x, and because they're direct variation, they're always going to go through that center point. They're always going to go through 0, 0. Okay, so that gives you one easy point. It's just a matter of finding a couple of other points to go with it. Now, how much am I going to mess you up if I say, let's start with example B?
Yeah. It's just some form of
I know it's a crazy thought of going out of order. Okay, if you don't know what a graph looks like, you don't know how to graph something, what's a basic technique we can always go back to? Pretend we don't know y equals mx plus b yet. You can always set up what? Did I hear Trevor say something about a chart? Yeah. If you don't know what a graph looks like, an XY chart, start plugging some numbers. My favorite number of all time to use an XY chart?
0.
0. Now,
Big brain.
these are just going to be lines. Y equals kx, so kind of like y equals mx. They're just lines. What are some other easy numbers to use?
1 and 2.
I can handle 1 and 2. There are days that I will say, okay, you need a negative in there, so throw a -1. Today's not a day. You don't have to include negative. So you know what to do here, right? Put in 0 for x. -2 times 0 is
0.
0.
-0.
Put in 1. -2 times 1. What is -2 times 1?
-2.
-2.
Where my head's at today.
I was waiting for someone to save you.
I was like,
-2, put in 2. -2 times 2?
-4.
-4. Okay, you've got 3 points. 3 points you can always graph a straight line with. You know where 0, 0 is, yes? And in case you've forgotten, remember the horizontal axis is x-axis. The vertical axis is y-axis. 0, 0 is in the center. How do we graph 1, -2? What do we have to do, Justin?
You go to the right one and down 2.
Does that sound right? Right 1, down 2?
yeah.
First number tells you left or right.
Yes.
Second number tells you up or down. So right 1, down 2. How do I graph 2, -4? What are we going to do, Mac? Okay, right 2. This time we go down 4. Okay, they form a line, yes? Connect them. Sorry, I stink at straight lines. So I like to use a ruler, which I will say, I know it's still COVID times, but we're kind of past the point of thinking that everything transfers via touching stuff. So I do have some rulers up in a basket up there you can borrow when you're in the classroom. But planners work great too. I agree. The planners work great. I mean, it's about the same flexibility of this ruler right here. So you just have to have the planner with you, which you're supposed to have with you. Okay. Let's backtrack to A. Why did I skip A?
Fractions.
It's a fraction. Now notice I didn't just skip it and leave it in the dust.
You should.
I skipped it just to, okay, let's break you in with an easier one without a fraction. And now we're going to come back and talk about one with a fraction. Okay. So, again, I'm going to encourage an
Graph.
XY chart. Now, easiest number of all time to put in, it always is
0.
0. I'm going to put 0 in the middle because I'm going to do something different this time.
1/2.
But now, when we multiply something by 3/4, and we're graphing this, it would be really nice if it came out as a whole number. If I just go ahead and put in 1, I'm going to have to graph a fraction or a decimal.
Lovely.
So what can we multiply? What kind of numbers can we multiply 3/4 by that will avoid the whole fraction or decimal answer? Okay. Why 4? I like the 4. Why?
Because both numbers can be multiplied by 4.
Yeah.
Okay, you'll get 12/16.
Well, okay, we'll have to review how we multiply here. It's not that both numbers can be, it's more the fact of there's a 4 in the denominator,
Yeah, that's fine.
so we're going to be able to cancel. So I like to use 4. Now, if I'm going to use 4, I'd like to have one other number.
-4.
-4 is the direction I was going. However, I do like hearing 8 as well. Okay, so positive 4, positive 8, negative 4. Those are all good options because they are multiples of 4. 12 would be good. 16 would be good. I know you're getting big there, but
4.
if they're a multiple of 4, they're good. So now, let's review. 3/4 times negative 4 is a fraction. What is negative 4 as a fraction?
Negative 4 over 1.
Oh, negative 4 over 1. Can you guys see that? I could zoom in some.
See if you do your cross
Yeah. Some of you are going to multiply that and say, okay, I have negative 12 over 4, and then you're going to divide it. Okay? I like to teach the fact that a 4 and a 4 will cross cancel. Now, there is still a negative here, isn't there?
Yes. So it's negative 3.
So 3 times negative 1 is negative 3. Okay, so multiplying by a multiple of the denominator is good. When I put in 0, 3/4 times 0
0.
is 0. What about when I put in 4? 3/4 times 4.
Should be 3.
Just be 3.
It should be
Right.
3.
The other one was positive 3. This one's going to be, the other one was negative 3. This one's going to be positive 3. So, we're going to graph. Negative 4, negative 3.
Left 4, down 3.
Okay. Left 4, down 3. My favorite, 0, 0. And then 4, 3.
Right 4 up. Yeah, right 4 up 3.
Right 4 up 3. Do they form a line?
Yes.
Yeah, then you've probably done something right.
I hope so.
You hope so, yeah. Yes.
Could you just do the rise of the run?
You could, and I'll teach that more in the next lesson. So, yes, slope, rise over run does work. If you remember how to do that, that's fine. You can do that. I'm trying to teach, go back to the basics a little bit, remind you guys of XY charts. I'll talk slope, rise over run. I think it's tomorrow. It's one of the next 2 days. Okay. Now, and that brings up, why, if you look at the 2 graphs I've graphed, why are my lines facing opposite directions?
Because the numbers you have are different.
Yeah. This was a positive 3/4. So this has a positive slope. I know we're not officially talking slope today, but this is a negative slope. So this angle's down instead of up. So now, with that in mind, C.
It's going to angle down.
It's gonna angle down like B did.
Yes.
Okay. Let's try C real quick. I need some X values.
0.
I love 0. Why 3?
Because it's the denominator.
Because the denominator.
Negative 3.
And negative 3. Or another good one would be negative or positive 6.
6.
Okay. So I use negative 3, 0, and 3. Okay, the first part is the hardest. Negative 2/3 times negative 3. Negative 3 is a fraction. Negative 3 over 1.
Mm-hmm.
The 3's
2.
will
Cancel and you get 2.
cancel.
Because the negative.
A negative times a negative is a positive. And it's 2. 0 times anything.
0.
Positive 3 times negative 2/3. Negative 2. Okay. Now, I'm going to have to zoom out. It's negative 3, 2, 0, 0, and 3, negative 2, but my graph's all the way down at the bottom. You know what? I'm just going to hope you guys got those values. I'm just going to zoom in on the graph. We've got 0, 0, negative 3, positive 2.
Left 3 up 2.
Good. Left 3 up 2. Positive 3, negative 2.
Right in the middle of the graph. Really
Right 3, down 2.
I really thought you were going to go with 0.
Except I already did 0, 0.
Yeah.
I jumped ahead on that one. Okay. Better?
Yeah. Still a straight line.
Yep. And if you get anything other than a straight line, again, I'm going to say you made a mistake. Figure out where your mistake happened. Okay, your homework is lesson 2.2 in Math Excel. You got around 15 minutes right now to work. Use this time.
Hey, it's not good this time. So we got 3%.